Hi everybody, welcome to the Engineering Bard Show. We're going to start right here. Thank you for everybody tuning in. And we're going to do the pre-code first. It's more like the preliminary before we sort of code it, kind of have a little bit of understanding. This right here is a triangle wave. See how it starts at 0? The period goes from here to the end of this wave. Recall in the last video there where we had the sawtooth wave. It's pretty much two sawtooth waves put together. So this right here is the function is going to come in right here, the amplitude. We're going to pass the amplitude. The amplitude is from 0 to 3.3 volts. So that can vary the height of the square, of the triangle, excuse me. Okay, the increment is the amplitude divided by the steps. That will give you, on the for loop, it will give you increments. So the increment is when it stops here, how many increments will it take? So, and so on and so on. Now, as we climb, we're going to go to the top right here, but we notice on the sawtooth wave, it just dropped down. That means we need another for loop that starts at the top of your amplitude. And the top of your amplitude, then we subtract it. Subtract it going down, we subtract it. So right here we add it. We add the increment to the loop. And right here we subtract towards loop. Okay? Does everybody understand that? Leave a comment if you don't. But I assume that everyone just got this like a trap, you know what I mean? Okay? So the total time, this time is divided by 2. Time is in microseconds. Okay, so microseconds. So from 5 million, which is 5 seconds, to 1, well, I hope you put more than just 1, but it can go pretty fast. So you want to divide it by 2 because the total period is half of this. So half of the time is going to go here, half time here, and then half time here. Does everyone understand that? Okay, so next we're going to go to the code part after this.
Welcome to Code Talk. How's everyone doing out there? I got a new sort of setup. I got this NVIDIA broadcast camera going on. I got the little setting. I think there's a setting where it's like eye contact. Put in so my eyes will always scope you guys out like the Mona Lisa. You know what I mean? All right, here we go. Let's build this triangular wave. All right. So, first step, what are we going to do? Oh, all right. Yeah, you're right. Put in our name. I'm going to move this guy over here. Okay, here he is. He's over here, okay? So, what's the second step? Okay, so second step, no, we don't start coding. No, that's not a good idea. What you want to do is put in this embed JSON right here. See that? That right there enables the printf to work and enables the floats. Okay, so I already typed all the stuff in, so I think this way is going to be a lot faster. Okay, what's next? Yep, we got to do that clear screen. Remember that code, the clear screen, 1xb, the cursor, printf. Okay. What's after that? The home screen. Yep. It's going to be like that almost every time, especially if you want to input values. Okay. So home screen, print S. Now, what we're going to do to make it more, I wouldn't say, was it professional? Yeah, maybe it's professional. We want functions. Functions, especially when your code gets more complicated, you want functions or you want separate files. So let's create a function. Void triangular step int. There's going to be steps, and there's going to be amps and float, just like we did on the pre-code, except this time it's just on the code. What we do, we got to declare variables inside the float. Okay? So we got a temp amp, I, increment, amplitude, okay? And we got int, temp steps, temp period. Why is it temp period? Because remember in the video there, we want to make sure, we want to keep it jerk resistant. Jerk resistant, yes. And of course, it's not going to be jerk proof because you can put all kinds of stuff in it. We don't want our program to crash. Okay? So amp goes to temp amp, steps goes to steps, period goes to period. Okay? So what's after that? Okay? After that, we want to create something where we have a user trap. This is called a while loop trap. And so if you follow it correctly, we want to make sure that they put in the parameters. What do I mean by parameters? Like steps. We want steps from 0 to 476, something like that. Float, we want amps to be 0 to 3 or 0.5 to 3.3. We want period to be, we want it to be in microseconds. We want it to be from, 1 to like 5,000 or something like that, just 5 seconds or 5 million, excuse me. And so we want to make sure they're in this trap. So here's the while loop. Okay. So let's say they put in a figure that's below 0.05. So like say they say put 0 in or a negative number. Then what happens is it's going to boost this up over here. It's going to put it down here where it's actually true. And if it's true, then basically, and this is an OR function. Remember the OR function? So if that's true, and if it's over 3.3 true, they get stuck in here. It's kind of like a little while loop trap. They have to put it in there. The everything won't work until, and this is a printf. This is kind of nice. And then it breaks out of the loop. It breaks out of the loop and it goes back to here, and it's going to check it. It's like, is that template? Is that guy cool? Is it below 5? Oh, it's not below 5. It'll do it again until they cooperate and they get the right answer of your right parameters. So 0.5, okay, steps 14096. You don't need any more than 4096 because it can't do more than 4096. So here's a value between 1 and 4096. Scan, there you go. Breaks out of the loop, puts it, tests it again, make sure he's cool. Do the same thing right here. Put in another while loop. We got to do it for the period now, from 1 to 5 seconds. I don't know why I put that, but we'll just, you could put it slow, but just make sure the period is not a negative number. That's the most important. There's no such thing as negative time. Well, unless you're in the universe or something like that. Okay. Sorry about that, guys. Let's put me over here. Okay. Let's go ahead. What's after that? Scroll up. Okay. Scroll it down a little bit. Okay. And then right here, I'm going to circle my cursor right here. This is where the math begins. So your temp amp is going to be between 0 and 3.3, and it's going to go into amplitude. Okay. The increments is temp amps divided by temp steps, and that's going to be the increment. Okay. Temp period divided by 2. Why is it divided by 2? Because remember, the period is that whole triangle. Okay. And that whole triangle is, we got to split the difference between half the saw wave as it goes up to the point, and then we got to divide it as it goes down to the point. So we showed on the board there how the increments work. So the amplitude is going to be how high it's going to go. Increments, how it adds it up. So 1 plus increments, bam, sends it to the out, sends it to the main. Okay. So pretty much, it's a pretty good size, it's a pretty good size function right here. So, yeah, it's pretty good size. Okay, now, oh, darn it. Okay, then let's go ahead and go down. Now, you see that right there? This is where, this right here is, we call this, right here is the welcome wagon. The triangular waveform, it appears onto the screen. Okay. Let me get this guy out of over here. Because sometimes this will go away. All right. So, triangular waveform. So right here, make sure you return it. Returns it right there. Sometimes you have to add this print F right here, because otherwise it just won't work. I don't know why. It just won't work. So you got to like fiddle around with it. Okay, enter the number of steps. Scan F. Remember that is steps. Enter the amplitude from 0 to 555 amp and period. Okay. I'm going to be a nice guy. Here we go. So I'm going to give you 3 seconds to take a picture of that code. 1 potato, 2 potato, 3. Okay, good. All right, let's go all the way up. All the way up. Remember to print screen it, put on the word. Okay. Okay, ready, stop. Let's go ahead and copy and paste this right here. Okay, I'll give you 5 seconds. I'll give you 3 seconds. 1 potato, 2 potato, and 3 potato. Okay. Or we do one more because it's kind of a long program. The int main. What do you guys notice about this? There's no while loop in here. Not cool? Yeah. That's because the while loop is in this function right here. So it calls this function, and then it goes over here. So there's no such thing. I think I accidentally, but there's no such thing as a super while loop. It's just a while loop. That's all it is. Okay, so remember to put your clear screen, your home screen, your float amps. This is the welcome wagon. You enter the steps. And, yeah, let's go ahead and do it. So, just hang tight. I got to hit the, so let's go to the, oh, where is it? I think it's serial monitor. Okay. So hang tight. I know this screen is fickle, but hang tight. Okay. There you go. Enter the number of steps. So let's enter the steps. Enter 1,000 steps. Okay, we want it to be 2.5 volts. Okay, enter the period in seconds. I'm going to do 10 milliseconds, which is 10,000. 10, 2, 3. Okay, we're generating the waveform. Okay, let's pause the video. Let's go check it out. There you have it. There's the triangular wave. Now let's go ahead and we're going to adjust the settings. Maybe get it a little bit faster. Maybe get it a little bit more rough. All right, so let's do that. Okay, let's go ahead and change it up a bit. Okay, let's say we put it to 5 volts. And enter the period, use hold seconds. Let's get it pretty fast. Let's get it 1 microsecond, so that's 1,000. You see how it goes to enter the value between 3 and 3 forms? And we still don't have a waveform. So let's put it 2.5. And now we have something. Okay. So do you guys all see that? So there you go. That's the even when they put the error in and go back to it, it stays the same. There is a sawtooth wave. See how it's triangle-like. And I'll see you next. Next, we're going to do sine waves. So I'll see you next on the Engineering Bard Show.